Hi there and thanks for watching. If you like the content of this video, please like and subscribe. Hi, my name is Jonathan Hopp and I'm the instructor for this course. We're going to create a REST API using Spring MVC. Okay, so Spring is a framework that has a bunch of modules in it that we can use to create our own REST API. And we're going to use all of them together, and I'm going to show you how you can get your own REST API going pretty simply. Now, it doesn't cover every single little thing. There's a lot of other concepts you would need to make a production-ready REST API, including security and other modules that Spring gives us, but this gives you the basic start that you'll need to create your own API. Now, as far as what you'll need for this course, you're going to definitely need IntelliJ community. That's going to help you actually code the Java. I would also highly recommend Postman because you're going to make API calls. And you'll also need your own SQL server. So you'll need some sort of SQL server with a username and passwords that you can set up later, so that way it will store the actual tables. I'm using SQL Server, so I use SQL Server Management Studio to look at it. And I have my own SQL server with a name and passwords. So you should be able to have one yourself, and that way you'll be able to set it up later. And that's all you really need. You'll be surprised at how fast you can get a REST API going using Spring. It gives us so many tools and so many things out the box to make this quite fast and simple and make us really efficient developers. Well, let's get right into it. So it may sound weird to get started with Spring by going to a website, but that's exactly what we're going to do. So we're going to go to start.spring.io, which is the beginner site for Spring. So you're allowed to basically pick your language, your project type, whether it be Gradle or Maven, your Spring Boot version, and then some project metadata. So just basically some basic stuff. We're going to do obviously Java. We're going to pick Maven, and we're going to use 3.11, which is currently the default. You can name your thing whatever you'd like to name it. Packaging is jar. I'm just using Java 17. And then we can add dependencies. Here's the fun part. Once you click add dependencies, there is a list of all the kinds of different things that you might want to use when setting up your Spring application. So again, we're doing a REST API. You might be doing other things with yours, so they let you choose. The three dependencies we're going to look for are Spring Web, Spring Data JPA, and MS SQL Server Driver. Okay, that is what we're going to use for our REST API. Okay, Spring Web will handle all the REST stuff. So for example, the routing and the controllers and all that good stuff. The JPA will help us to store our data in SQL. And then the driver, we need that in order to actually communicate with the SQL Server itself. So these dependencies we will need, so make sure you've got these dependencies checked off. And then at the bottom, it'll have generate. What it will do is it will create a zip file based on your project name called demo.zip. If we go into it, then you will be able to see that there is an entire project in here. So all you basically need to do is extract this zip file wherever you want to go, and then you can open it up in IntelliJ, and then we can get started. Now, before we dive into Spring, I just want to make a note about the SQL server. So I've opened SQL Server Management Studio, and I've got my own SQL server, and I've got a database already made up. All right, so you want to make sure that you've got that going. I just gave mine this name. You can name it whatever the heck you want to name it. That way, you'll have some place to hold the data. So notice how we have nothing in here. So eventually, we're going to actually have the JPA and Hibernate take care of our database for us. But let's take a look at that Spring project. All right, so Spring, you'll notice, came with a lot of stuff out of the box. I made some packages by right-clicking on com.example.demo. I just named mine demo. And I made a controller package, a models, and repository. That way we have some folder structure for our application. Because as applications get bigger, you're going to have more classes. And if you put everything in one big pile, it can be very, very confusing. Now, Spring, you'll notice, comes with a lot of things out of the box, which is great. There's a lot of things that Spring does that we don't want to do by hand. Okay, there was an existence before Spring existed, and that was not a very happy time. All right, so you'll notice that automatically in the side of demo application, the main class, we've got this the main method, and it runs the application. And we've got our first annotation at Spring Boot application. You don't really have to do anything with this, all right, for our example. You don't have to really touch this. This is boilerplate. This will get the app started. That's all you really need to kind of know. The app will not run just yet because we haven't set up the database, but if once we're able to do that, we're going to hit play. I'm going to show you what it looks like in the beginning. You'll see a little bit of ASCII art, which is nice. And then it will say that it's starting up, but because we don't have this connection to the SQL server set up, it's going to fail, right? Which is not a big deal. We'll get it set up, but just to show you what starting it up looks like. All right. So I've got a controllers, models, and repository folder. I just by adding packages, I made these. Let's start with model. Let's say that we're going to build a e-commerce site. So we have products. Okay, these products represent products that we sell to customers. All right, so we have maybe like some sort of like front end like React app, or maybe it's like an Angular app that will display a beautiful list of products that people can shop for. So our backend API needs to provide that information. So we have a class called product. I imagine that a product has a name, right? It has a description. It will have also whether or not it's on sale. So is on sale is a Boolean. And we're also going to say it has a price. So I'm going to use big decimal for price. Okay, because big decimal gives me that precision that makes me feel comfortable using it for money. Right? Now, we're going to make some getters and setters. Okay, I'm going to use the generator from IntelliJ to go ahead and do that by doing Alt Insert and then selecting. As you can see, it just makes getters and setters for me. And you could use Lombok for this, but some workplaces actually ban Lombok, and some people embrace it. So I figured just generating my getters and setters with IntelliJ is fast enough. It only took a few seconds. All right, now we have basically a basic Pojo. It's got fields, it's got getters and setters. Nothing fancy here. So where does the Spring come in? Well, the cool thing is what we can do here is that we can use annotations to let Hibernate, the JPA-Hibernate, actually create a product table with these columns, okay, and keep track of it. So it actually will update our database for us. So what we can do is we can use annotations. So the first annotation we're going to use is entity. Okay, and at entity above the class is going to let Spring know, like, hey, like the JPA should think of this as a table in the database, right? And that's all we have to do. We just have to put at entity. These annotations are why Spring Boot is so awesome, because we can just use an annotation and then that's it. It does a very complex thing for us. We don't have to type it out. Now, my product does not currently have a primary key, so I'm going to add one. I'm going to do at ID, which is let's JPA know, like, hey, like this is the primary key. And then we're going to do private int ID. Okay, so that's going to be, integer is going to be our ID. Now we need to actually let it know how to auto increment. So we're going to do generated value strategy equals generation type dot auto. All right, so it will auto increment in the database, which is very, very cool. All right, so that's what we really had to do. Like, that's how easy this is. So you can basically put at entity to let JPA know, like, hey, this is a table in SQL. And then you can say which of the fields represents the primary key with this at ID annotation, and then you can say different generated values. We're using SQL Server, so it's generation type auto. Depending on what other database management system you use, you may have to change this to something different. You'll have to look it up and see which thing you'll need, like SQL Server uses one thing, MySQL uses a different thing. Just look it up. It's not you'll see plenty of examples online. But this is really all we need to get the table going. That's how much little work it took. All right, so you may be wondering, like, how on earth is Spring going to actually connect to the database and use the JPA to update the tables and do all that database management stuff for us? Well, we need to tell it information about the server in order for it to actually connect and do the things it needs to do. Under the resources folder, there is a file called application.properties, which is beautiful because this file is loaded into Spring and it contains all the configuration that we need. Okay, so as long as you can put configuration in this file, it'll get loaded when the application loads. So you notice that we have like spring.datasource.url, spring.datasource.username. Okay, these are the properties that we need to put into this configuration file and to give them the proper values. That way Spring will know, like, hey, this is the username, password, and the URL of the server that I am connecting to. All right, the other thing we have is this hibernate.ddl auto. So the JPA Hibernate is what is managing our tables. So I just put it to auto update. So that way, in case you add columns, remove columns, add tables, remove tables, it will keep the database in sync. Okay, you may want to change this for a production type environment depending on what you're doing, but getting set up is perfectly fine. All right, so you can go to the GitHub repo to get the different types of things you need in order to connect to your database, but you can go ahead and paste them in and fill in with your own data. And then I'll show you what it means for the JPA to actually create this table. So remember, we had this product class that was an entity. So it's managed by the JPA. It's got a primary key of it's an integer ID, and then we had the auto increment stuff. And that's really all we did to actually make this. We didn't really need, everything else was just plain Jane Pojo. So let's go ahead and run our application. Right, and then it'll give us some startup stuff. All right, and then we'll see what happens. Blah, 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 JT platform. Okay, it says create table, see it says Hibernate. And then if I go to SQL Server Management Studio, I'm going to refresh real quick. And then you'll notice inside tables that there is now a product table. I didn't actually create a SQL script to create this table. The JPA made it for me, which is beautiful. So if I right click on it and let's say I look at the top 1,000 rows, there's no data in it, but you notice that there are columns. Okay, description is on sale, name, price, and if we look at the design of it, so we can see the types, then it basically made a SQL table with varchar and bits and numeric. Okay, so beautiful. We didn't actually have to do all that stuff, right? It may not seem much like for one entity, but if you have like a bunch of entities in your program, like a bunch of different ones, this saves so much time. All right, so now we've got a model, which is the product, and we have a table that can represent it in the database. Now we need to perform those CRUD functions, okay, that REST API stuff, in order for us to save data, delete data, all that good stuff. So now that we've created our entity and it actually wrote the table to the database, which is amazing, let's go over to the repository. All right, the repository's job is essentially to talk to the database. So it will talk to the database and say, hey, create a product or delete a product or update a product, that sort of stuff. So all the CRUD functions that we need. So we're going to right click on the repository package here. I'm going to do new Java class. So this time I'm going to do interface. I'm going to call it product repository. Right, public interface product repository. Now the JPA comes equipped with another interface called the JPA Repository, so we're going to use that. We're going to use extends JPA Repository. This is generic, and we're going to put two things in here. First is what kind of entity do we want the JPA Repository to work with, and what is the primary key. So I'm going to go ahead and import the product class. Now I got this because in the product class, notice that the primary key is an integer. All right, so since that is the case, that means that we need to put integer here. If it were a string, we would put string. Whatever we need to put here, we put there. Now, what if I told you that as far as CRUD functionality is concerned, we don't need to touch this anymore? Like, we literally just have this product repository, and that's all we need. Like, you don't even need an annotation. That's how simple this is, right? You'll see, like, when we do the controller, you'll see how awesome this is in a second. All right, let's make our controller next. I'm going to right-click here, do new class. I'm going to go ahead and do product controller. All right, now with annotations, we're going to make an annotation here, of course, and we're going to go do @REST controller. This lets the Spring know, like, hey, this is a REST controller. So all of that mapping, the HTTP verbs, get, put, post, delete, all that good stuff we get to use, like a regular controller. And all we have to do is just do an annotation. All right, also, I am going to do another annotation called @request mapping. And the reason I'm doing this is because all my endpoints in product controller are going to be API/product. I don't have to write API/product for every single one of my methods. It's going to be really annoying. So instead, I'll just put it on the top, on the controller level, and then everything inside the controller will begin with API/product. All right, well, I'm going to need my repository, so I'm going to need to inject my repository into my product controller. So I need to make it a field first, product repository. Let's call it product repository. And then to inject it, I'm going to do auto-wired. All right, so @AutoWire is another annotation, very, very useful. What it does is it's going to inject the product repository into my controller. And it's just an annotation that's amazing. Like, it's very, very simple. All right, now we need to start doing our endpoints. So if we're doing CRUD functionality, so we're going to do get, put, post, delete. So let's start with get. So to do that, it's very simple. It's more annotations. So for get, we're going to do @get mapping. Right? So by just doing @get mapping, this will be the regular get. And then we can start writing our actual methods. We're going to do public. Since this is going to be get all, we're going to start with get all products. So we'll call this public list of product. We're going to use the interface list. And then we're going to do some importation of things. So alt ender, import the product, import the list. Okay, we'll do get all products. Okay, it doesn't take anything in. Now here's the crazy part. All we have to do is use a repository. So we're going to do return this.productRepository.findAll. Now you may be wondering, what the heck? We didn't write a findAll method. In fact, if you look at the repository, look at IntelliSense, it has findAll, it has save, it has save all and flush, find by ID, it has all of these like methods. And the reason these exist is because back in the repository, we extended the JPA repository. Okay, that's it. It provides all that functionality for us. We do not have to write all of this boilerplate code, and that is beautiful. All right, so now when we do this, we do get all products, and this will actually get all the products. Or we could basically say, okay, cool, we can get a product by its ID. Now to do that, we can do @getMapping. This time we're going to do parentheses because it's a URI parameter. We're going to do quotes, squiggly braces, and then we're going to call it ID. Right? That lets the like Spring know, like, hey, we're expecting it to be like /2 or /3. Right? It's going to be API /product/1. Right? As opposed to just nothing afterwards. So we want to get a specific product. So we'll do public product get product by ID. And then, of course, we need to get the ID. Now, how are we going to actually take this value that we get from the URL and put it inside of an actual variable? So all we got to do is do @path variable int ID. All right. So as you can see, annotations everywhere. All right. Annotations, annotations, annotations. All right. So to get the URI parameter, okay, to get the path variable, all you got to do is use the @path variable annotation. All right. And this time we're going to actually go ahead and do return this dot product repository dot find by ID. All right, now you're gonna notice it's gonna be red. We're gonna hover over it. Okay, so find by ID, okay, is not going to give us a product necessarily. Oops, I forgot to put the ID here. Find by ID. All right, so it's going to be red here, and it's going to basically be like, hey, this is an optional. So find by ID actually returns an optional. All right, so that's why I wanted to point that out, that we're not actually returning the product, we're returning an optional. And if you don't know what an optional is, an optional essentially is kind of like a wrapper. Okay, what it means is it could contain a product or it could contain null. All right, but it's sort of a wrapper around, okay, either of those options allows us to work with it. So we can't just straight up return it like this. So let's go ahead and work with it a little bit. So we're going to do optional product. Okay, so optional takes a generic. We're going to have to import it. Okay, product equals this dot product repository defined by ID. All right, now we've got two options. So either the product existed in the database or it didn't. So like, cool, right? So if product dot is present. Okay, so this is present will let us know, hey, like it found the product. Product is not null, right? Otherwise, we'll do something else. All right, so if the product is present, we're going to return the product.get. All right, so .get will actually get the product from the optional. So you can think of optional like a box. Okay, it either holds the product inside of it or there's nothing in it. Okay, it's one of the two. All right, so if there's something in it, then that thing is present. And then if it's present, you can get it. That's the way I think about it. So if it's present, you can actually go into the box and grab it out of there. If not, we want to return a 404. So in this case, we actually can return an exception. We're going to throw new response status exception, and we're going to do HTTP status code HTTP status dot not found, and we can leave a little message saying could not find product with that ID. Okay, so now we are able to handle both. So basically, if it is found, we will return the product, and the automatic response we'll get is a 200 OK, so we don't have to actually do anything with that. And then otherwise, if they didn't find it, we're going to throw this response status exception with not found, and then we can use the HTTP status enum to give the proper code, and then we can put a little message here. All right, so we got both options considered. Okay, we have to use optional, but optional is not that bad. All right, I do have a video on optional in case you're wondering how it works, if you'd like to go into that in more detail. All right, so let's do one more, and then we can start actually testing this API out. So let's do @post mapping. All right, so this is the post. We want to create a product, so we're going to do public. Typically, when you create a product, you return the product you just created. So public product, create product. And then we are going to do @request body. Okay, so this will expect a body so we're sending a body which will contain the JSON for the product. So what Spring will do is it'll be, okay, cool, I'll grab, it will receive the request, and then in the background, Spring MVC will be like, cool, I will transfer this into a Java object, which is really sweet. Okay, again, annotations do all the work for us. So it's a product, and we're going to name the variable product. Okay, so this will handle all that serialization, deserialization, all that fun stuff. All right, so we've got our product. What do we do with it? We are going to actually go ahead and look at the repository. So this dot repository, product repository dot, and it is called save. Okay, so we're able to save the product. All right, so we're going to actually return this. All right, so return this dot product repository dot save product. All right, and because this is a post mapping, we want to return a 201 if we create something. Because it's important that we give the right codes back whenever we have an API, so what we can do is we can add another annotation here, and we can do response status here. So as a response status, if you hover over it, you can look at the different things it expects. All right, so we use response status, and then we'll do value is equal to created, HTTP status dot created. All right, so that means if it's successful, it will give back a 201, which is what we want to be able to do. So by default, if everything goes okay, we get back a 200. Otherwise, there is a default like 400 code or 500 code that Spring will give if something goes wrong. But sometimes we want to be able to be a little more fine-tuned and give the correct response status. All right, this is actually enough to get going. So what we're going to do next, we're actually going to test out our API. I'm going to go ahead and restart it so that it can run with all the new changes. And then we're going to go open up Postman, and we're going to actually try this out. All right, so we are in Postman, and I am going to start using the API. All right, so I've got a request set up. So it's localhost 8080. If you're wondering where I got that from, it wasn't just magic. If you go ahead and look at this gigantic wall of text, I wouldn't blame if you didn't read all of it. It'll say Tomcat initialize with port 8080, and so since that's the case, it's running locally on localhost, so that's where I got that from. All right, localhost port 8080 /API /product, and where that comes from, if you want to go back to the controller, is in product controller. I've got this API /product under my request mapping, but it's on the annotations on the controller, so therefore everything inside the controller will start with API /product. All right. Now, if I do a regular old GET request, there's nothing in the database currently, so I'll just get this blank array, which is fine. I'll get 200 OK, so everything's hunky-dory so far. So let's actually add some data to this, because we want to actually look at stuff. All right, so breakfast cereal. I did Captain Crunch, the best breakfast cereal next to cornflakes, and let's go ahead and do a post. So it's the same. I have the body, raw JSON, and I made a JSON object. Okay, and we're going to actually do it, and it gives us back Captain Crunch. All right, and then let's do a couple more. Let's do cornflakes. Okay, which is the best cereal ever. Best breakfast cereal in the history of the world. Okay, it is also, I don't know how expensive it is. I don't remember. Right, but there we go. We got cornflakes, and let's say we got, I don't know, Count Chocula. Okay, which is the healthiest cereal in the multiverse. Okay, and let's say, I don't know, it's like $4.75 or however much it is. All right, so what the heck is, let's get rid of this, and let's go ahead and post. All right, there we go. Now we put some data using post, and again, that was made possible because we've got post mapping here. So post mapping, right, and then we used a repository to save the product, so I made that request. It went through the whole pipeline, and there we go. Now to test it out, I'm going to go back to my get, and I'm going to actually get everything. So we'll get all the products and see if they're in there. Bam, there they are, Captain Crunch, Cornflakes, and Count Chocula. Now, can I look them up by their individual IDs? Yes, I can. So I'm going to do /102 and see if I get Captain Crunch. Bam, I just get Captain Crunch. So it looks like our gets work and our create work. So now all I got to do is update and delete, and then we've got our basic CRUD functions, people. All right, so this is how easy Spring makes making an API. All right, so even here, you notice that we were able to get everything back into JSON. It handles that for us. Oh, also one thing to note, when we post it says 201 created. All right, see how this is not 200 but 201, and that is thanks to the fact that we put response status.created with HTTP status.created here. That allows us to set the code that we want. All right, let's get started on making the update and the delete. All right, let's continue on. Let's do delete because that's pretty easy. So we're going to do delete mapping, at delete mapping, and it's going to be for a specific ID. I don't want to delete all my products. I just want to delete them by their IDs. So I'm going to do a string and then squiggly brackets and ID, and then we do public void delete product, which will take a path variable. That's how I grab that ID, and which is an integer and ID. All right, that's, remember this is what was, so you're basically saying, hey, it's going to be API/product/ some number, and then I want to take that number, which is the path variable, and save it in this ID. All right, and then after that, it's pretty simple. It's this.product repository.delete by ID. All right, and the product repository is that JPA stuff, that JPA repository. And remember, I don't have to actually write any of my CRUD functions. I don't have to write the implementation. It will take care of that for me, which is fine. All right, so I'm going to restart my server, and let's try this out in Postman. All right, here we are. Let's say I don't want Captain Crunch anymore. So Captain Crunch's ID is 152. So let's go ahead and do that. So I'm going to do a delete request. Localhost 8080/API/product/152. All right, let's see if that works. Oh, one thing I do need to do before we get to this part is the response status, because deleting should give it 204. So response status value equals HTTP status dot no content. All right, there we go. That's how it should be. I'm going to restart my server so that the changes can be updated, and then we will try it. Okay, so response status value equals HTTP status dot no content. It takes a second for it to start up, but when you see a started demo application, you're good to go. All right, so we're going to try to delete 152. Let's see what happens. 204 no content. So if I go back and I get all my products, I should not see Captain Crunch, which I do not. So my delete worked. So that was perfect. So we saved the best for last, which is updating. So we're going to do at put mapping. All right, and so we're also going to ask for an ID. Okay, to make sure we are updating a specific one. All right, and then we're going to do public product update product, which will take a from the request body, we will get a product, and from the path variable, we will get an ID. So you can use them in combination with each other, which is pretty cool. All right, so now we're going to do the update. So first I want to check to see if this product actually exists. So we're going to do optional product to update is equal to this dot repository dot find by ID. All right, so I'll give it an optional. Remember, an optional is a box. It could hold the product or it could have nothing in it. All right, so we don't know until we actually ask the database, hey, does this product actually exist? So if product to update, okay, dot is empty. So basically that means we didn't find it. Okay, we're going to throw a new response status exception of HTTP status dot not found and be like product not found. So it's like, sorry dude, like you asked for a product that didn't exist. We're going to give you a 404. Have a nice day. All right, but now let's say we actually did find the product and now we want to update it. Now I don't want to update everything about the product. Let's say that it would make sense for product to have maybe its price updated, because like prices change. Prices are going down, hopefully, and so we will be able to lower prices and give our customers a better deal, or we can maybe change the description. I don't want to change everything though. All right, so we're going to allow the person to change those two things. So what we can do then is we can take the product to update from the optional, update those things from the request body, and then save it. All right, so we're going to do product to update dot set, let's do dot get to actually get the product from it, and then we're going to do set price to whatever the incoming product's price is. So product dot get price, and then product to update dot get dot set description is product dot get description. All right, so what this monstrosity of a line means is, hey, this is the optional, cool. Let's check inside the box. Is there a product inside of there? If there is, go get it. Okay, we know it is because if it were empty, we wouldn't even get to this line. Then take it, set its price to whatever the price of the incoming product is. This is going to come from the JSON. Okay, we're going to do the price and the description. Everything else, we're not going to allow the user to actually update it. And then once we're done, we're going to do product to update dot get so we're actually going to return this. So we're going to do return product to update dot get. Okay, and then we're going to do dot save. Oops, actually we're going to do, sorry, my mistake, this dot product repository dot save, right? And we're going to actually save the product that we've been actually updating. All right, so just go over this logic. Is a lot more here than there has been the other ones. I have an optional of a product. I'm basically checking to see like, hey, does this product actually exist? Like, is there a product number 5? If there isn't, if the optional is empty, I'm going to go ahead and throw a response status exception and say not found, and let them know like, hey, there is no product by that ID. If I do find it, then I'm going to basically change the price and the description of the product and then save it. All right, so the save part is the same as we did in the post when we created something. All right, so we had to go grab it by its ID so that way that the JPA knows that it's doing an update as opposed to an insert. So it will keep track of that for us. But now let's give this a try. I'm going to restart my server and we're going to try to update one of our products. All right, I'm going to do a new request. I'm going to make it a put. I'm going to do a localhost 8080/JPA product. And then let's change cornflakes, which is ID 103. So /103. I'm a lazy programmer, so I'm going to go ahead and grab the body of this. What is it? Cornflakes. So body, raw, JSON, and then it should only change the description and is on sale. The description and price, excuse me. So the description is going to be, so we can get rid of the rest of this. We're going to do description, the best cereal in all the multiverse, and its price has gone down. All right, and so we've got everything here. Let's go ahead and send the request. Okay, 200 OK, and notice that the description is the best cereal in all the multiverse, and the price is $3.75. So if I do the get with all the products back here, okay, we can see that we have updated cornflakes. So now that it has the price and the description have been changed. Okay, the other stuff we did not allow to change. Maybe in the future we will. We could add that in. All right, so now we've got all our basic CRUD functions. We can get by ID. We can do a post to create something. We can delete something with delete. We can even update one of our products if we want to with a put. We can do more with this. So that JPA repository has some really powerful stuff that I'm going to show you in a second. But now we've basically got a REST API with products, and we were able to do this very simply by using the JPA and Spring Boot, Spring MVC to put all this together with these annotations and get this going pretty quickly. But wait, there's more. So far, we've done basic CRUD functions, create, read, update, delete, which is fine. But the repository can do more than that. It still continues with the theme of we don't have to write the implementation because there's a lot of common things that programmers need to do. All right, so far we can just do basic stuff. Let's say we want to let the user be able to find a product containing a certain string. So let's say we're saying like if you look up maybe corn, you'll get cornflakes or corn checks or whatever it happens to be. Like if let's say you're searching for something, that's a pretty common use case. Now that's not a basic CRUD function, so you might think, okay, well that we can't actually have that. But wait, you can. All we have to do is be able to use certain syntax within the JPA repository. So we have a product repository extends JPA repository, and this is what gives us the power to do what we're about to do. So let's do public list of product. All right, so this is an interface, right? So we're just going to put the method signature here, okay, of the thing we want. Now we're going to start with find. All right, so the way this is going to work is we're going to write this method name according to kind of a pattern. And as long as we follow the pattern, it will do what we want. So we're going to do find by name containing. All right, and then we'll do string name. What if I were to tell you this is all you have to do? By writing find by, okay, find is the first word we use, then by, and then we give the name of the property. So it'd be like find by price, find by description. All right, now if you just did that, you would have to have a matching name. I don't want to just have like a matching name, right? Because if it's search function, if the person doesn't remember the whole name, it's not going to be very useful to basically give them nothing back if it doesn't match exactly. So I want to do containing. So what this will do is it will search the whole string for whatever I decide to put in here. I put string name. We don't actually write an implementation for this, but this will actually work. Like it will actually find products containing a certain name. Why? Because this name matches, okay, this name here, this field is named name, okay, so it will go based off of that. So behind the scenes, Hibernate's going to use reflection, okay, which basically means it will take the product object and it will know what fields it has and will be able to use that to write the implementation of find by name containing for us. Now, if you still don't believe me, let's actually give it a try. So let's go back and let's kind of rewrite our get all products a little bit, because this was just plain Jane get all products. Now we want to have query string parameters. What I would like to do in Postman, I want to be able to kind of do this. Let's go back to my get. So if I did API/product, would be cool if I could do like name equals corn, for example, right? Where I want to look for like things that have corn in them. Okay, cool. So this is a query string parameter, which means we start off with a question mark, and then you can do name equals corn, and then if you have multiple ones, you can do like and. All right, so I want to be able to do that, which we got it. We can use there's annotations for that. All right, so we're going to do @request param. Now they may or may not give us one. All right, so for example, they could just put API/product and that's it, and that's fine. Or they may put API/product question mark name equals. So this is optional. So this is a great use case for optionals. So I'm gonna do optional, and I'm gonna put we're gonna do string, and I'm gonna call it name. All right. So I'm gonna say basically that there's a thing called name. Okay, that name equals, but it's optional. Okay, it might be there, it might not be there. Now let's change the logic inside of get to actually check for that. So if name.is present, so I'm going to say, hey, is that present? If not, we'll just do what we normally do and give them back all of the products. If it is present, let me clean this up a little bit. We're going to return this .product repository .find by name containing, okay, and then name.get. All right, now this find by name containing this comes from the repository, and we want to use this because we start off with find, because that is the pattern we have to follow, by, and then the name of the property, in this case name, and I want it to be like within the string, not to equal it, but be within it, so I put containing. All right, I constructed the name of this method by following the pattern that the JPA wants me to, and now I'm able to use it. So let's go ahead and restart the API and see how this works. Okay, so it started, and let's go ahead and do name equals corn. All right, so let's go ahead and put that in, and just going to do that cornflakes. Now, just to kind of show you how it works, we only have one thing with corn in it. Let's go ahead and do like maybe a couple of them. Like let's do like corn checks. All right, and then do that, and then I'll post that to create corn checks, and maybe like I don't know what other thing we could put in here, maybe like corn flakes, corn pops. I think there was something like that back in the 90s. Okay, if I remember correctly as a kid. Okay, it had corn, it was very fluffy. All right, so now let's get all the ones with the name that contains corn. See how it gave me corn pops, corn checks, and corn flakes? All right, so if I could just put flakes in here, for example, like flake. Notice how I didn't put flakes. Okay, exactly, we just put flake. Okay, but because it contained that string, okay, I was able to get it back. Now, what's bonkers about this whole situation is the fact that I just did that by following a naming convention. So I start off with find by, then the name of the property that I would like to search for, and then I put the word containing because I would like to search for it by that name with containing that string, right? So it contains the word flake. You don't have to remember the whole thing, it'd be equal to. If you didn't have this, if you just did find by name, then they would have to match perfectly. It would have to they would have to be like corn flakes, Captain Crunch, like an exact match. But I didn't do that. I did find by name containing, and then the JPA did everything else for me. So now I was able to use query string parameters. So to go back, if we look at Postman, I did this question mark name equals flake, and so the way I captured that is by using an annotation. I did @request param. In this case, it was optional because they may or may not give me a name. So what I wanted to be able to do was what happens, they could give me a name, or they don't have to have it. They can just give me this request, in which case they get everything. All right, so I would like to be able to do different things based on what kind of requests I receive, which is fantastic. So request param, optional string name, and then if the name is present, I will go ahead and use this method, but if it's not present, I will just give them the regular find all. And so now we are able to use query string parameters like request param And we also know how to use the JPA to basically build implementation for methods by just giving it the correct order in the naming of the method, and it will figure the rest out itself, which is really cool. We can do even more complicated stuff than this. I can easily see there being a requirement for our API for someone to be able to search for prices within a range. All right, so we can actually do that. So I'm going to make another method, public list product, because it would return a list of products. And we're going to do the same strategy. I'm going to just make sure I name the method following the convention that the JPA wants me to give it, and then I'll let the JPA figure out the implementation, which is bonkers. We're going to do find by name, because we're to do find by price, all right? Because I want to be able to give them like a lower price and an upper price, and give me everything inside of it inclusive, all right? So if I give it like $4 and $10, it'll give me everything that's within that range of prices. Find by price between. All right, so between will require two parameters. So we're going to do big decimal lower range and big decimal upper range. Okay, I don't have to do implementation myself. I'm going to just go ahead and let the JPA read the methods, the name of the method, and figure out what algorithm I want it to use. And then I'm going to give it the variables, okay, lower range and upper range, and then it returns a list of product, and that's all that I need to give it. So let's go ahead back to our get mapping, all right, and let's go ahead and add this new request parameters. So I'm going to do at request param, and then I'm going to do optional, and then we're going to do big decimal, and we're going to do lower range, and then we're going to do at request param, optional, big decimal, upper range. All right, because again, they may not necessarily give me these two. So we go back to Postman. What I'm picturing is that they're going to do upper range, like lower range, and upper range, something like this. Lower range equals 2, upper range equals 5. All right, so question mark, and then notice how with the second parameter I have this and, okay, this ampersand. All right, so this is the kind of request I'm expecting, and so you can have multiple request params here, and I use optional because again, they may or may not give them to me. All right. Now, again, I'm going to try to keep this very simple. Okay, because obviously you might be thinking, well, what happens if the lower end is higher than the upper end, or they do something goofy? Let's just keep it simple. Let's just say, okay, cool. I've got lower range dot is present and upper range dot is present. Okay, so they got them both. All right, and then we're going to return this dot product repository dot find by price between lower range dot get and upper range dot get. Okay, we could put a little bit more validation here, but I want to keep it nice and simple. All right, so now we're able to account for that. I'm going to go ahead and rerun the server, and we're going to give it a test run. All right, so I went ahead and added some more products. I'm going to go ahead and show them to you. All right, so just to give us more range of prices. So cornflakes, Count Chocula, Frosted Flakes, muesli, granola. Okay, some stuff's more expensive, some stuff's cheaper. All right, so now we're going to put question mark, lower range equals 2, upper range equals 5. So we don't expect to see Frosted Flakes or muesli. We don't expect to see granola either. So let's see what happens when we make this request. All right, 200 okay. So we got corn pops, corn checks, Count Chocula, corn flakes. All right, so it filtered out the stuff that was 2 under it. So if I do like 1, for example, I might be able to get the granola because it's $1.75. Or if I bump this all the way up to 17, then I should be able to see the muesli because it's $60.75. So now I'm able to search for my different products based on their price and with a range. And the way I was able to do that is back in the JPA repository, I did find by price. Okay, so remember, find by is those magic words that the JPA gives us. And then we have price because that is the name of the property I'm looking for, and I use between. And I give it 2 variables, upper range, lower range, and upper range, and it does it for me. All right, in the product controller, I can use request params to grab what I want, and I made them optional because maybe they give them to me or maybe they don't. If they do give them to me, I'm just going to go ahead and call find by price between and give it the values that are passed in from the request params, and then that's it. And I was able to do something even more complicated than even searching for it by the name. All right, so there are a ton of other things you can do by using the name of the method, okay, to search for things or to get things between. It is extremely versatile. There's a list on Google. If you Google it and look at some more and experiment with it, you'll see how powerful this is and how productive this can make you. All right, so the cool thing about this application is that we've made a REST API. Not only that, we can also handle any of the requirements that product may throw at us. Now, it doesn't have any security, all right, so it is pretty much open to the internet, so I wouldn't necessarily throw this up just yet, but putting all these pieces together, using all these annotations, you can see that Spring Boot can really make us productive programmers. Hi there, and thanks for watching. If you liked the content of this video, please like and subscribe.